All right, we're live now.
All right, welcome to episode 78, Into the Wood Chipper. I have Chris Fado here. How's it going? Shit, I
You
totally got that
still
wrong.
fucking up, Matt. Welcome, Chris Fidel. We appreciate you joining us. We appreciate enough to say your name correctly.
I was like, do I tell him? Do I?
I'm not even drinking.
Maybe that's the problem.
It is a problem.
Remember that episode where Phil
Always.
tried to do it sober and it was just so bad?
Good.
Should we start over? Or just
No,
keep
no,
on?
I'll
No,
keep this in.
This is the
I want it.
content
Yeah.
people listen to.
Fantastic. So, anyways, Chris, how's it going?
Good. How are you guys?
Well,
Everyone takes a sip of
alive.
water as I ask.
Yeah, things are good here, man. Just
Cool.
refreshing the election coverage every 2.5 seconds.
I know. Checking my phone like crazy. There's been no
Yeah.
changes today. The day after election. It's just like, oh, I guess nothing's changed at all.
Like an hour ago, Georgia was down to like 3,000 votes. It's like, come on, guys, like
Mhm.
you're almost there. Count faster.
We'll see.
Yeah,
It's
I mean,
all real
it's
close.
been such a wild week, and I'm so tired. So, this is a perfect time to be recording a podcast. As it is. So we brought Chris on because we want to talk a few different things. First off, Chipper CI, you've been making some noise in the community about that. Kind of tell us, like, how did that come about as an idea, and like, what are you hoping to, like, what kind of value are you hoping that brings to the Laravel community?
Yeah. Okay. So me and David Hemphill were at a conference. Oh, why am I blanking on the name? The Startups for the Rest of Us conference. What do they call it? MicroConf. What was that? Over a year ago. It was the last in-person one they did, thanks to COVID. So we were both there, and I saw, like, kind of over my shoulder, looking at his screen, he was messing around with CodeShip. And I also had used CodeShip at work, and then I just like recognized the like, oh, nothing's actually working the way I thought it would. I better like adjust this and then rerun a build and adjust this. And I was like, oh, I've been thinking about this idea for a Laravel specific CI thing to him, and we started talking about it then. And then after the conference, we decided to work on it because the idea just kind of kept pinging around in our heads. So that was really the birth of it. And what was that in 2018? 2019? It must be, or sometime in 2019 that conference was. Because then we worked on it for a few months after that, and we got our first paying customers at Laracon. That's the next Laracon, whatever that was. That was 2019 Laracon in New York, I think they did it. I didn't go. My wife was like pregnant and I just wasn't gonna go. So the kid was doing it.
It's the only one I went to.
Oh, really? Okay, so the one I didn't go to, the one we didn't go together. My wife was, I don't know, 8 months pregnant or something, and I wasn't allowed to leave the house, essentially, which is still true 2 years later, or a year later, actually. But that year we got our first paying customers at Laracon because we like really quickly put together, we had coded on it long enough and it was working, and I wasn't like totally sure it wouldn't fall down when real people used it, but it was working enough. And then Taylor used it to show off Vapor as part of like a continuous integration thing, because I'd been talking to him about it a little bit, so he knew it existed. And then we knew he was going to do that like a week ahead of time or something, and just like try to get as much like of the stuff that would let people sign up done as possible. And we just had like a coupon like hard coded in there for people to sign up, so they got a reduced rate for the first year if they signed up during Laracon. So that was our first few paying customers from that, which was pretty cool. Did I answer any of your question? Why did it come about? What value do I hope that it brings? Something like that.
I can jump in with the question of what makes it different from any other CI, or why would I use this other than something else?
So we definitely like, this is both like just to get it up and running, but also just kind of the mentality of me and David are in. It's just that it's trying to be simpler than other stuff. One, it's geared towards Laravel, so you don't have to worry about like the setting the PHP versions. It doesn't have this module in it and all that kind of stuff. It's just kind of like, if it's in Forge, it's in here, and maybe some extra stuff too. So very much geared towards simplicity. We don't have YAML, so you're not. So this is funny too, but so you don't have to use YAML at all. There's no YAML that you can use. It's just you configure the pipeline in your Chipper account for each project, and there you have it. So the deal. Go ahead.
Is it actually DevOps if it's not YAML?
I mean, that's the deal. Like, I have sort of come around to the conclusion that people actually like complexity. You know, it kind of makes you feel smart after a while if you figure it out, like, how something works. So, like, maybe that was the wrong move, like, business-wise, but the simplicity I still like a lot. Like, it was kind of like we ran into all these issues in CodeShip, and it's really hard to get everything working. So we wanted this thing to kind of just work for Laravel people out of the box, and mostly it does that. You know, CI is still complicated. Like, everyone's application still has such very specific needs, especially around their environment variables and all that kind of stuff. So sometimes, you know, people still hit issues with just figuring out how to make their application work. And I haven't really figured out like a great way around that. It's kind of like you try to make debugging as easy as possible, but there's, at the end of the day, it's like still really hard to get people to have like a really super easy experience, especially if their application is, you know, has some level of complexity.
So, I mean, I guess like with CI, then your hotness is GitHub Actions. Like, have you compared kind of like what GitHub Actions offers you out of the box versus like what Chipper CI is offering?
I mean, yeah, I mean, but the deal is that it's very specific to Laravel, right? So it's like a PHP, it's Node, and Composer and stuff like that's pre-installed, and you know, we have some tooling around figuring out like where logs are and that kind of thing to help debug, you know, failing builds and that kind of thing. But otherwise, GitHub Actions is, you know, geared towards everything and anything. So their ecosystem is neat, right? Like, you can build your own images as little action runners, and that can do anything, right? Because you could just make one as being part of the GitHub community and publish it to their marketplace or whatever. So there are things that will like generate templates for like ECS if you're using that in AWS, and something that'll deploy to ECS as well. And like, you can kind of get really complicated with that. We actually take still, this might change, but we take like a read-only approach to all our stuff also. So we don't have tooling to like make PRs against your code for code style and that kind of thing. You know, that's like a style CI type of thing instead of what we're trying to do. So basically, we do a little niche thing very specific to Laravel, whereas GitHub Actions is like, you know, everything. Like, I use GitHub Actions for some Golang projects I have to auto build on when I push a tag. And another use case I have is at work, we use it so that when we release it automatically grabs the last commits since the last release and makes kind of a nice review of the commits and PRs and that kind of stuff have been merged in.
No, that sounds really cool. And I mean, as someone who uses Laravel, you know, it is nice to have a tool specifically built for Laravel versus trying to shoehorn my Laravel app into GitHub Actions, if that makes sense.
Right.
So like under the hood, like, are you using Docker to build an image for every CI job that has to run, or are you doing it a different way?
So there is one image for the build image. And that's just what everyone uses because there's no like custom images or anything like that. Currently, not to say we have plans for that either, but it's more like it could go in any direction, and like that's kind of a whole nother conversation we could have too. Right now there's one build image. The build image has PHP 7.1 through latest, except for 8, and different versions of Node, and it has NVM, so you can install different versions and all that stuff if you want. So you kind of treat it like it's an Ubuntu server that you're just given, like a forage server, and you can do the same stuff with it. So that's one Docker image, and that is pre-built. So it's not like there's a stage of building a Docker thing each time, each build that's run. And then other containers that provide additional services are just pulled in. So there's you know, the database, so MySQL, Mariah, Postgre have different versions, Redis for cache, and that is basically it. You have those options to choose from, but there aren't like, we don't have an option of like pull in any image under the sun and then attach that or anything like that. But yes.
And you can run all of that without YAML is what I'm hearing. Like, I don't have to write any YAML to configure any of that stuff.
Yeah, right. Because we have a very specific use case, right? So the build container, the database container, the Redis or cache container, if you want those. If you don't want those, then it's just the build container. And they're just specific presets, and they're basically modeled off of what you can get at Forge with some extra stuff. Like we went down to MySQL 5.6 because Aurora serverless is like, at the time, was pinned to that version of MySQL. So if people happen to be using that, that could be like a relatively close match to their production. So yeah, and that way we don't really need to make anything too fancy, really. It's still Docker, which is nice because the containerization and building stuff in isolation of the rest of like the host's computer server system is really nice. And also you get some options, like you can set a default version of a PHP and that kind of stuff in a container, and you don't have to mess with the host that it's running on. So that part makes that part of Docker still really useful.
Can you talk a bit about your actual infrastructure? Are you booting up environments for each run, and then these images inside that? Or are you running all the images on like a shared environment, or how are you isolating users?
Yep. So there's two versions of the build system. One is old and not used anymore, although it's still there if we need to roll back to it, because the new version is been around for a month or something like that, the new build system. So the thing we do is we just have some build servers, like 3 to 5, 2 to 5, something like that. It depends. So we use auto scaling in AWS to spin up servers and down based on business hours. Because one of the neat things is that it turns out it's the busyness of it and how much capacity you need is very much tied to business hours, which makes a sense. But it's not like there's spikes during Black Friday and have to have a ton of servers or anything like that. So like it's super pinned to business hours. So we have some auto scaling groups that spin down at night and up at day, with a lot of leeway because business hours in Europe is different from the US, and there's a fair mix of customers, mostly US based, but it's a mix. So we only have a few servers, like you said, right? So like I said, so we're not spinning up a server per build or anything like that, because the time to spin that up would be too much, really. Although there's some weird things you could do. Maybe you have some servers on standby and you just use them and whatever. But we didn't go down that route. The first version was super naive because it was like the first thing I tried and it worked well enough, and that got us really far. Like in our year and a half or whatever it is of having customers, that was like almost a year of that time, the older build system. And all it was is just, I don't know, however many servers. Each server had 3 workers on it, like, PHP Laravel queue work, PHP artisan queue work. And each worker could run a build, and each build was a long running job just in that queue, which was like terrible, but that's how it worked for a while. Terrible because the code became really complex in that one like job. No matter how much we refactored it, it was like ended up being kind of buggy, and Docker would do weird things like not stop when you tell it to stop, and then you'd have containers that were just hanging around in a server forever. But 3 to 5 servers, let's say, each server had 3 queue workers, so you could run 3 builds per job, or 3 builds per server. So obviously that's shared, right? You could have 3 builds running at the same time, sharing resources. But the Docker container, contains it as much as a Docker container actually does. No files were mounted into the Docker volume. Everything was kind of in the Docker container itself. So the host file system didn't really see any of those files, except that technically they are on the host file system because it's Linux. But they're contained within a container, essentially. What else is interesting about that? So it's easy to tell a container how much RAM it can use. So that's nice, but you can't really do that as easily with CPU. CPU is kind of like, do your best not to steal everyone else's CPU, but then it's like, sometimes that happens because it's like, it does its best job, but it can't, be perfect at that. Well, RAM is like a cutoff. It's like, if you go over this many gigabytes of RAM, then boom, you get killed. You get an hour out of memory error, and like the process is killed. So we had to be careful about that kind of stuff. The crappy part about this build system, it was very naive, right? So there's no scheduler there. There's no fancy Kubernetes or Node or all that kind of stuff that says, this server feels like it's overloaded. Let's put this job over here so there's enough resources. So you'd end up with busy hours where like 3 of the 5 servers were completely at capacity, and then 2 of the servers had no builds on it at all, which is super annoying. And that kind of stuff got weird, and we wanted to add more and more features to this thing, but every time we wanted to add a feature, that one build job was like where we had to cram some PHP code, and really no matter how much you refactored it, you're still just adding code into this one long running queue job, which was getting complicated because PHP is very bad at async, right? It doesn't have async, and like there's like these weird shims for it, but they're really hard to get to actually work. It's like super hacky. It feels hacky. But there are things we had to do periodically, like check, did this job get canceled? Like there's no kind of two-way communication to be able to say, like a user clicked the cancel build button in the UI. So like then PHP has to respond to that. That's like not really a concept in PHP because it's just like run this and this and this. So it's like in the loop that listens for build output using like the Symfony process classes. It had to like keep track of the time and then keep track of how many seconds elapsed. And if it was over a certain amount of seconds, then it would be like, okay, did the build get canceled? Nope. Okay, continue. Okay, send this output to pusher, like the latest output, and then save something to the database and then fire off a notification if you need to, and just all that kind of stuff. So, and then when the build finishes, we like had to find log files and download them. And so they are available. So you could download your log files or like dust screenshots or something, like all sorts of stuff. So all that code got really complicated. It was all in one long running queue job. We couldn't really split that out into different jobs. God, the reason why is stupid and complicated. I'm trying to remember why. It was hard to do that. And it had to do with like making sure build order like happened in the correct order. Like you don't want to have 3 builds pending for a project, and then like the latest gets built, and then the middle one gets built, and then the oldest gets built. Like they should be in order. So like the thing we did to like keep that in order was like kind of complicated. And I wrote this up, and I'm just like totally blanking on the really in-depth, like kind of more interesting reason of why like chunking that up into different queue jobs is not as easy as like you'd think it would be.
All right. Thanks for coming on, Chris. It was great. Appreciate it.
Okay.
No, keep going.
It's all good. That's going to bother me now, but that's okay. So anyway, we had reasons to move to a new build system. So, new build system had a few goals, and those goals were to not be a long running job that could just like fail randomly, and like it was really hard to catch errors correctly, like try catch finally type stuff and all that good stuff. So and also resources weren't being used effectively, like as effectively as we wanted to. So it was kind of time to find like a real Docker based scheduler. Or, we could rate our own thing that had like was more aware of servers and that kind of thing. Oh, that reminds me. Thank God. So the reason why it was hard to chunk that up into different builds or different queues is because the queue would have to know what server the build was running on. Like the job would have to, and we didn't have a good way to say like this build is happening on this server. And like this queue only picks up jobs that are for the server or something. So like you'd have to dynamically create, like the way Laravel works too, like you'd have to kind of dynamically create a queue per server, that kind of thing. And then we spin up servers in an autoscaling group and kill them. So then that would be very dynamic. And then, that just gets into like just super complicated stuff. So the idea of like the application is one thing, and it has its queue workers somewhere, but the queue workers talk to an API, like a totally separate thing, to start builds, kick off builds, and keep track of build status, is like a much more attractive option. So like a totally different system to run your builds versus the app that's just like fires off some queue jobs, like not long running at all, just as long as it takes to like make an API request. So the new build system ends up being that, right? So we have the application server, and there's like a worker server that just is running queue workers. And the new stuff is based on HashiCorp's Nomad, which is, way, way, way less complicated than Kubernetes. simpler to operate, but also has some really good concepts for builds, like the idea of a batch job. And it has some tooling around batch jobs, which are nice. So, it's not meant to be a service. It's not a web application that's run, and it's not load balanced across 3 different servers or anything. It's just one batch job run on one server. And when it's done, it, is seen as successfully completed and is terminated. And it has an API. So you just kind of ping the API, tell it to run, and that's kind of it. Of course, the complicated part is knowing what is happening in the build system and how to run jobs against it. Because before, in the old build system, we just ran, we did a Docker Compose up. We built a YAML file, by the way, not user facing, but it existed. And that was a Docker Compose file. And that Docker Compose file had the settings and everything. So you did Docker Compose up as part of that queue job, and then ran Docker Compose exec, and it just executed commands that were in the people's pipeline. They're predefined commands. And that way, right, we had PHP code doing that. So then PHP could get the output and then update and send that to Pusher, and then we'd get updates and they could view it in the browser and all that good stuff. Now in the new system, we have Nomad, and Nomad will just run containers, but the containers have to do the build because there's no PHP. There's no easy way to just run and execute ad hoc bash scripts against a build container that way. So this got into me writing a bunch of Golang, because Golang does concurrency very well in asynchronous type stuff. It's concurrency instead of asynchronous or whatever, but effectively, it accomplishes a lot of the things PHP won't, because it has that. The other nice thing about it is that it compiles into a small binary, and that binary is easy to pack and throw into a container and just run somewhere. And so you don't have to have a whole PHP or whatever, Python, Node.js, Ruby runtime. You just have the Golang binary that you have when you compile it down and build it. So that's really easy to move around and just put in containers and then run. So the builds build themselves. So the Chipper CI sends off a queue job to Nomad. Nomad spins up a job with a definition, right? You define what the job is. So there's the build container job, the MySQL job, a Redis job, whatever that is defined. The build container has a little Go binary in it, and that Go binary runs the build. So it has the pipeline scripts and all that stuff, and it just runs them each sequentially and then sends off the output to a little microservice, which is another Golang thing. And that Golang service, the microservice we have, it's kind of as dumb as possible. It's just a relay. So it gets a connection, a gRPC connection, which is also kind of a fun thing to talk about, from the pipeline runner, the thing that's in the build container running jobs, running the pipeline scripts, and it sends it, results and statuses and, the chunks of build output as they come to the microservice. The microservice just sends out a job to the queue, to SQS is what we're using for our queue. And then Chipper reads those in. So Chipper CI just sends out a job thing, and it's waiting for status updates from a build from the little microservice that pumps out jobs into the queue. So more complicated, more infrastructure, more servers, but way better, less bugs, and Golang is also faster. All the builds ran faster because Golang's magic and just is faster, which I think is due because my personal theory is that Golang can do concurrency, right? And just reads in the output of whatever you're running much more efficiently than PHP. I think that was kind of the stuff, because all of a sudden, it doesn't really make sense for a NPM run to build your static assets to run faster. Just because you sent the command from PHP versus sending the command to Golang, because it's still just Node.js doing something. And the servers weren't super different or faster underlying the servers we chose for builds. Although that changed too eventually. We also eventually changed the server type in AWS that we're using to have way more RAM and actually worse CPU, but the more RAM made everything faster. God, there's so many aspects to it. Jesus. So I'll stop there for a second. What do you want to talk about?
So, before this, were you familiar with Go at all, or was it that was a whole new thing for you?
I was, but I didn't have much in production, but I wrote a bunch of it out of curiosity and just to kind of have fun, but I never like had a good chance to put stuff in production with it. Like I forget what the kind of standard Golang book is, but it's really good just to like, cause I wanted to learn something new. This is of course before I had my second kid. Cause like, how the hell would I ever have time for that? But, reading a book, geez. So like I did that and learned some Golang, which is neat. And then did a bunch of random things, or like I would try to start maybe do some stuff for work, but then realized no one else was using Golang or had any idea what they were going to be reading. So it got converted to PHP. But I wrote a bunch before, hadn't put any into production. So I wasn't unfamiliar with it totally. I had a good head start in it here. Definitely still learned a bunch of stuff, but, Golang is really neat because I was totally scoffed at people who said, "Oh yeah, it gets rid of a whole class of bugs," meaning like type related bugs. But I've actually come around to that opinion. You still write bugs. The bugs are just more interesting. They're not like, "Oh yeah, in Linux like capitalization matters," whereas in my Macintosh it doesn't. It's like not like that stupid type of bug, or it's not. I passed a null instead of a string, and like that got converted to an empty string, but that still caused bugs somewhere down the line. Instead, the bugs are like, I have no idea how concurrency actually works, and like everything's fucked. So like the bugs are way more interesting, which is kind of neat. Just in that it's like learning something new and you're fixing those bugs, but also just that it's more like business logic-y bugs, or concurrency bugs, which is almost the same issues and almost the same thing in some instances.
So I'm interested in how you like chose which parts are Go and which parts are PHP. So what's your current kind of breakdown now where those boundaries are?
As little Go as possible. And that's because, well, first of all, I don't know if this is like a hot take, but I think PHP and Laravel specifically is like the best in class language for web work or web stuff, which of course is biased because I just know how it works more than other frameworks and stuff, but also because like I just like the tooling in Laravel is so good for certain stuff, and that certain stuff is like the 99% use case of like writing a form and accepting form input and validating the form and throwing it in the database and getting it back out and paginating and like that garbage. Like if you don't have all this tooling, like it's just so crappy to have to write that stuff in another application. Like, okay, I have to do forms and form validation again. And like, it's just like, sometimes it's just really crafty and terrible to work with. Like in Golang, like I don't ever want to figure out how to do that in Node.js or Golang because the tooling is just not as good. Like it's just so much more stuff to do. Like I have to find which package is like good for HTML validation or HTTP validation for forms, and figure out how to display that on the other side, and just not doing that in another language. So like as much as PHP Laravel as I can keep going in, just because the tooling is so nice for like queue workers, like even just doing that in another language is a huge pain because you have to think about like, I guess I'm writing a forever loop. Is that how you write a queue worker? Okay, I guess so. But like it's just taken care of for you, taken care of for you. So the major contributing factors to Golang are concurrency and async, or concurrency specifically, because the build runner has to do a bunch of things at the same time. It's not just running build scripts. It's also saying, okay, I need you to tell me if the build is canceled. So two-way communication is important, right? So if like, it's not just sending data out. It's also saying, all right, you have to tell me if the build gets canceled so I can stop. The concurrency allows for doing things like having a timer in the background because there's a 1 hour time limit. So like at an hour, everything just dies. And like there's a thing that's sent to the microservice saying this thing stopped because it reached an hour time limit. And so that's like a little timer in the background, right? It's like a window.set timeout in JavaScript. And so those two things are kind of like things that have to be ready to accept connections or just be happening in the background. So like that's an asynchronous or concurrent need while it's like running pipeline scripts and all that stuff. It's also more efficient to do some stuff concurrently. For instance, sending the alerting the microservice about updates happens concurrently while it's running the pipeline script. It's not kind of like really competing for time there. It's not like in the PHP, there's a for loop. So like the for loop just freezes and sends something out to pusher, and then it continues on to the next thing. Where like in Golang, it's not being held up like that. And the other reason to use Golang is because it's really first class support for gRPC, which is the way the microservice and the build thing is communicating to each other. So it's not like an HTTP API. It's gRPC, which runs over HTTP2 as a long running connection. And it has it's really nice because you define a schema, a protocol using protobuf. And that just defines the messages that get sent back and forth and like the data inside of the messages. So you have this thing and that generates code for you. So you can actually generate PHP code into this. But the Golang support is kind of first class. So I used it for that reason. And then also because it has the ability to stream. So it's a long connection and it just keeps sending new data in one direction or both directions and that kind of thing. So again, that's another like nice thing with concurrency. It can like read in a stream while it's doing other stuff and accepting other connections. So those are the two main reasons for Golang there. I mean, and I wanted to. I do not lie to myself at all. I just wanted a Golang thing in here instead of just more PHP. Like I spent all the time learning Golang. I'm not just gonna like throw it away. It's like
no, I mean you should build something cool, right? Yeah.
Seriously.
Yeah, I mean, like, you could rebuild Docker, I guess, because they're all written in Go. So you can just like start a new Docker.
Sure, why not?
I mean, why not? So the other thing I saw, like I was reading through the news, is that like you made a switch to the AWS's API gateway, and you was able to kind of like offload a lot of your webhook handling. Like, how did you, like, were you being overloaded with webhooks at first, and that's kind of what the solution was, or was there just kind of like something fun to play with?
Both, but definitely the first issue is overloading the server. So you get so GitHub's apps. God, there's so many layers to everything. Okay, so there's OAuth apps, right, with GitHub, Bitbucket, and GitLab. You do the OAuth flow, and then people hook up a repository, and it creates a new webhook. And each project has a webhook, so it'll send you webhooks about it. GitHub Apps is like on top of their OAuth concept. It also has OAuth, but it's a separate thing. And you get one webhook input for anyone who installs that app onto a repository. And some people install the app into their entire organization because that's like an option. So we could get webhooks for every repository in their application, even if they've only set up like one or two projects in Chipper. From that organization in GitHub. So it's really easy to get overloaded with webhooks. Now on top of that, sometimes they go down. So like Bitbucket especially will go down sometimes. And then when they come back up, they just like will flood you with every webhook that like should have been sent over that period of time when they had an outage. So I read about that from like a Circle CI blog. That I don't know if that's actually happened to us. I think it did once, but by then we had the newer setup. So like I didn't even know about it. So the original thing is just an application server, and it just had the webhook send to our code. Just a Forge server. So like that got overloaded. I don't know, not fairly often, but often enough because like sometimes I would check the access logs or the PHP FPM log, and you see the error that says, hey, your max children has been reached. And then you check the Nginx logs and you see, oh yeah, some of them got the 503 or whatever error you get back in that case. So I wanted a solution there that was not load balancing and more servers, because that's not cheap, right? Because you got to pay for a load balancer, you got to pay for multiple servers, then multiple servers, the database has to split out, and I think we always had an RDS database, so that was always split out, but Redis wasn't. And then you're just keeping track of more things. It's just annoying to have all that stuff. And also like a new server is like, I mean, if you get a cheaper one, it's $5, but ours are a little more beefy than that. So it's still like $30-$40 a month per application server. It's not high, but more, you double that. If you get 3 servers, you triple that. And if you have a load balancer on top of that, they do quadruple your server costs. Whereas I could set up API gateway and like the scale isn't great. It's just the PHP kind of like sucks at handling many concurrent requests at a time. It's not too hard. Even if you bump up your PHP FPM settings a lot, it's still not hard to like hit a peak and like then some webhooks are lost. So API gateway at our scale is way cheaper. It's like, a few bucks a month. Okay, so API gateway we started using, and that pushed a job to SQS immediately. So, their queue service, Amazon's queue service. And then we just read in the job and ran that against our application. But the fun part there is that we had all the HTTP controllers set up and all that good stuff to accept webhooks. So we set up the queue job that was listening for those in a way that it kind of like pretended to make an HTTP request against the application. So we didn't actually need to change any application code. We just added a new job, and that job like pretended to make it an HTTP post request because the SQS job had all the HTTP info in it. So I had like the security headers from the webhook and in the JSON payload and all that stuff. So that was kind of a fun way to not have to like recode or retool anything and keep all our unit tests and all that stuff that had been set up for that. Then we ran into an issue where the JSON payloads for some people were too big and hit SQS's limit of like 256 kilobytes, I think, something like that. Because some people would have a huge list of commits in their merged PRs, and that would just create a huge JSON payload. So then we needed to ship that off to S3, the JSON payload, so that the SQS job could just like reference it and not have the JSON payload inside of it. But that that's not easy to do. You can't tell API gateway to both send something to S3 and then also create a new SQS job. But you could send something to S3 and then have some like other extra stuff in AWS that knew when S3 had a new object in it and then just kicked off a job. But like, that's just a chain of like stuff I didn't want to deal with. So we used Lambda instead, which is like, it's still another stupid thing I had to set up, but I did it anyway. But this is, again, I wanted to use Lambda because it was cool. So it doesn't have to be a great business decision. I just decided I wanted to do that because that sounded fun. So the Lambda is really, actually, that might be the first bit of Golang because, again, I wanted to use Golang. So that's our first bit of, I think that was the first bit of real production Golang, is this Lambda function that called when API gateway was used. So the Lambda function does some extra work to decide if it's GitHub or GitLab or Bitbucket. And I forget something else. It shoves the job in S3 and then fires a job to SQS. And the SQS just says, here's the location of the JSON payload, like, S3 / chipper CI webhooks, whatever the bucket's called, / 123, whatever the ID is for the project and team and all that stuff. So then the SQS is just doing the exact same thing, but it's still the same job that pretends to send a post request into the application, or it makes a fake HTTP request into the app. It's still the same job that just reads that, except it grabs the JSON payload from S3 instead of just reading it from the SQS job. So that's like the chain of events that led to where we are now, because everything kind of just like overloaded the server, and then the JSON payloads were huge, and that's where we ended up. And that handles scale really easily, like way more scale than we'll ever hit probably on the cheap.
So, I mean, like in retrospect, it sounds almost like it was like easy to figure it out. But I mean, how much headbanging did you do trying to figure out the whole SQS size limits or files and shoving it into the S3 instead, things like that?
Okay, so API Gateway, I used API Gateway version 2 was not out at the time I was doing this. Version 2 is a little simpler. API Gateway version 1 is like the one that's fancier and has all the options in terms of like, using infrastructure as code to like define your entire API and doing all this stuff. And so I was doing that, which was, just more complicated than it is now, which is fine, but like, that's some headbanging right there. But then the other thing is that I had mentioned that we get the JSON payload from the HTTP request, and then that gets sent to the SQS job. But you have to like tell AWS how to do this transformation of like the data in, and then how to transform it so it actually creates an SQS job. And Bitbucket, hey, is there a theme here with Bitbucket? Bitbucket was the one provider that consistently would fail to create an SQS job for some reason. Like it would just not encode JSON correctly, or I don't know what was going on with it. So I spent days just monkeying around, like, all right, do I base 64 this? And do I do this other transformation? And then like it has to be in a very specific order for Bitbucket because otherwise it fails. Like I can't just base 64 encode like the JSON string. I also have to like I forget the details, but I had to like do this weird stuff and then get it in the very specific and do it in a very specific order and way, kind of fighting like this weird syntax of what of AWS used, which was like a Java based something parser. I don't know. I forget exactly. Maybe it's James Path or something. So that'd be like the JSON tooling or something. Anyway, so that was like just horrendous headbang. It just like Bitbucket just would not work. The way we have it now gets around that issue completely because you just save the JSON string to an SQS or an S3 object. So there's no monkeying with it at all. And, you know, once I got that initial thing done, it was like the rest kind of fell in place. So for all this infrastructure stuff, I'm using Terraform to define the infrastructure. So there's like a lot of examples out there for that kind of thing. It's actually kind of a nice way to figure out how AWS's API works. Because if you can find a Terraform example, you kind of see what is required to like create infrastructure inside of AWS because it maps to their API pretty easily, pretty one-to-one for the most part. I'm also in a DevOps Slack called HangOps. So like it's hangops.slack.com, I think. And its community is like just super, super helpful and great. I'm in there all the time for work, for side projects and all that stuff. And that was a huge help for so many steps of figuring out how AWS worked.
Was there anything you hit during this process where, like, maybe you had to write the code yourself, or you just wish there was an open source alternative that you could have used?
I don't know. I think I've like way too in the headspace of like learning about this new stuff, like wanting to do that. So I just kind of naturally gravitate to that. Because there are other things, like I could have jumped right into using Nomad or something, or if there's hosted services that do container stuff for you, it's like, why the hell am I not using that? So like ECS or EKS, right? So Elastic Container Service, Elastic Kubernetes Service. So they call it Kubernetes Service. They came up with another name that was K. I forget what AWS does. Hosted Kubernetes on DigitalOcean, all that stuff. One, I don't want to learn Kubernetes. I still don't know it. It's like super complicated. I don't want to. Thank you, Matt. Then Nomad is much easier. Also, the hourly cost of build hours for all these services are double to triple, just like an EC2 server hourly cost. And I had a third. They just like didn't do things like we needed a build container and a Redis container and a MySQL container, and that would get funky. That would get funky in like if we try to like cram this as an AWS code build thing and just kind of piggyback in code build, which is their CI tool in AWS. And then like ECS and especially their Fargate like serverless option, the spin up times could take too long to be like effective. It would be like you waiting 1 to 10 minutes for a build to start just because AWS just had their own stuff going on and didn't want to start your build yet. So there are alternatives for the build system, but it just like nothing really felt great. And Nomad like gives you the full control. Like of course I'm also learning how to like manage a Nomad cluster, but it was and is kind of simpler enough to wrap your head around, so that's not too bad. AWS auto scaling is really nice also because once you have everything set up, it takes a while to get everything set up. And that's like a whole nother like, wow, I just spent a month of Terraform, like code diving and examples. And like once it's done, it's like it's done and works pretty beautifully. So like to have Nomad, new Nomad clients auto join the cluster when they're spun up in AWS. And also when you kill a server, you have to do that gracefully. So there's like a whole another ball game of like stuff to figure out when your AWS auto scaling group is going to kill a server. You have to like make a hook for that, and that hook has to like send another SQS job, and then your code has to do something like stop services or just jobs gracefully on this Nomad client, and then tell AWS it's okay to kill that server. So there's all sorts of stuff there. I can't think of any other places that would make sense to use an OS and an open source alternative. Certainly the build system would have been the place to do it. Hosted services were expensive, and I just like other stuff I've played with before and never like felt good, like the open source versions of whatever.
Yeah, so I mean, to set it up a super easy softball to pitch another one of your services. I mean, this is very DevOps heavy. And you also have a book that I think a lot of us kind of consider, I don't want to say the Bible because certain people will probably crucify me for that, but like it is kind of looked on as like a really good book, Servers for Hackers. Is that something that is totally completed and done with, or like are you still updating it with all the stuff that you're currently learning?
I don't have time for updating anymore because of the aforementioned children. So I used to update it for the Ubuntu LTSs. The last one I updated it for was 18.04, and 20.04 is out now as of a few months ago, which I haven't updated the book for. It would be nice too, but like, A, not a huge amount of things changed. And B, I just do not have the time. I don't know how I would make the time for that. Is it still relevant? Yes. Some things are annoying that I've changed. Like there's always going to be a new version of PHP. So like, I'm sure the book has like 7.0 or 7.1 as the example or something, but now 7.4 and 8 is going to be out very soon. And there might be some like minor configuration changes between like Nginx and PHP FPM and like how that talks to PHP. But for the most part, it's all the same and similar. So it's unfortunate, but if I get time, I definitely want to update it, but it's just like that's not happening right now. I am in process of adding a few extra modules to the shipping Docker course, because that course is 3 years old now or something like that. And Docker has a lot of new stuff, but like the fundamentals haven't changed at all. So that Docker course is still very relevant, but like just again, like PHP has moved on. So like this refresh is saying like, here's how you do a Ubuntu container based off of 20.04 instead of 16.04. And we're installing PHP 7.4 instead of 7.0 or whatever I had there. And then there's a few very minor like differences. And then Docker has some newer stuff towards how you build. It has like this thing called BuildKit. So like that's a newer way to build your Docker containers. And then multi-stage build steps are a newer thing, and using caches, you can like pull down a cache and speed up your builds by building from a cache. And then I'll have a module on using AWS's ECS, since the only other like production thing I had there was Docker Swarm, and now Docker Swarm is effectively defunct, even though the company who bought the Docker Enterprise stuff says they're going to keep updating it and adding features. Like nothing has really happened there. So the book is still relevant, aging, and I want to update it, but I don't have time right now.
I know that feel.
Kind of like me.
Same.
So we have a listener question from Jose Gonzalez, Savant on Twitter. What tech do you think will change how developers work, Laravel or otherwise, over the next 3 to 5 years?
I'm not sure I get it. What tooling is going to like improve Laravel or developers' lives, or like what's the next kind of like bigger thing?
Yeah, I guess technology in general. What do you see is coming up that's going to really change the way we develop software?
Oh my God, I can't believe I'm the one getting this question.
I'm going to assume you're going to say Golang, but
I mean, it's just another language. It's nice. It's got concurrency, so like that's this thing. It's got its rough edges, right? So like error handling in Golang is still funky. Like I've actually come to like it because you have to like handle every single error conceivable that's thrown off by a function call. That aspect is kind of nice, but like it's not Golang is really nice because it's not C, but it compiles and it's very fast and it has concurrency, and concurrency is first party. It's first class or whatever you want to call it. And it's like the way it does concurrency isn't difficult, but concurrency is inherently difficult. So no matter what you do, like it's still difficult. So Golang is cool, but it's just kind of like another language. I feel like, I don't know. Is someone going to replace Laravel? Is Rails going to go away? I don't know what's going to happen. I mean, in the server world, I think stuff like Nomad and Kubernetes is stuff you won't have to care about. So hopefully everything's just Heroku in the future, like different flavors of Heroku. Seems to be going that way. CI is like a commodity almost. So like GitHub has it, GitLab has it, Bitbucket's going to have it or has it, I forget. Chipper has it, and like, so what are people going to compete on? Everyone's got a big free tier. So like, that's kind of interesting in terms of a business challenge. CI and like automating stuff is like, more and more the norm. I would like to see is like just something that's friggin' simpler. Like, why do I have to know about Node? Why does Node always break? Why is that my asset pipeline? Like, it's just like, how is that the thing I have to deal with every day? And PHP is like still in the range of simpler, but then like even that's getting more complex with like Composer and package management, and everything is great. But then of course it's added complexity because you have a package manager now and there's version conflicts and all that kind of stuff. Servers are like, you used to just FTP servers, like files to a server, and it just worked. And now you have to care about every module and very specific PHP versions, and it has to have the right version of Node on it because we're all just building static assets on our production server, like a bunch of peons. So I don't know. Hopefully that stuff improves. Like I've had bad luck with Node.js, man. Just stop.
Yeah, I can tell there's some like bitterness in your voice every time you say Node.
I mean, like, do you want to, like, this is a whole nother podcast, but like, if you want to come back and just like talk about your Node problems, I think we can all relate.
Right. That's a very relatable topic. Maybe Adam Wathan will just like replace Node with something better. I think that's his next move after Tailwind. Just like take over the whole front end stack, please.
Go ahead.
Go ahead,
Chris.
No, it doesn't matter.
We have a follow-up question from Jose. What's your favorite style of hot wings?
Oh God. Shit. Okay. So in college, over a decade now. Yay. Good. I went to UConn and there was like a bar like somewhere, I don't remember anymore, and they did rocks and wings. So like you'd get like the little rolling rock ponies, like a bucket of them, and like you just select whatever wings you had. And they had really good wings, and they were like just a combination of like any kind, like garlic salt or like the classic kind of like Frank's Red Hot and all that stuff. And those are like really what come to mind as my favorite. All of which is to avoid the actual question because I don't fucking know. Do you know how often I have wings? I don't make wings. I have kids, dude. Do you know what I eat? I eat soggy French fries off of their plates. That's my dinner.
You can always put some hot sauce on the chicken nuggets. That's almost a really good one.
What I really
do
is
they call it boneless wings now. I mean, yeah, it's like pretty much
it is both the
same thing.
We go to Chick-fil-A, aka hate chicken, but I still buy it because I don't know, that's just too good. And then and we just get chicken nuggets. I don't know, dude.
I think that's Jack McDade's favorite chicken.
God.
All right. And on that note, Chris, thank you so much for taking time to hang out with us. We really appreciate it. Check out Chipper CI if you're doing low-level projects. I'm definitely going to be checking it out here in a little bit.
Nice.
If people want to follow you on Twitter or like learn about Chipper CI type things, like where can they find you on the internet?
Yeah, on Twitter, I'm most active at Fideloper, which is a combination of my last name and developer. So sure, that exists. Serversforhackers.com is where I used to be very actively posting active content, but now I am busy. Although I am like, as my second kid has just turned 1 and I'm like starting to slowly regain some time back. So like that'll hopefully be spinning up some more stuff there because I really enjoy the process of making content for that. Like if I could get paid for that, that'd be great. If I was Laracast, that would be amazing, but sadly I am not. So yeah, on Twitter at Fideloper. There's a Chipper CI account, but who actually follows business accounts? I don't. I follow people. I'm sure some people do, and I probably piss someone off, but I don't. Yeah. So don't follow Chipper CI because I'm great at marketing, I guess.
I mean, this is just a week to piss people off, so just go for it. Who cares?
Nothing matters anymore.
No, the whole world doesn't matter. Awesome. Well, thank you again. Appreciate it. Ben, it was nice seeing you.
You look pretty today, Matt.
Fucking adorable.
Good.
Thanks, all.
All right.
Yeah. See you guys later.